Our culminating task here involves everything that we've done so far. I know that sounds crazy. I know that you see a word, a whole bunch of paragraphs or 2 paragraphs here, and it makes you a little nervous. Well, that's the whole point of going over quadratics and how to find particular parts of quadratics. We're going to spend the next several weeks on them, and I need to make sure that you have sort of a basic understanding. So let's start with Acme Fireworks. The Acme Fireworks Company has been engaged to provide the fireworks for the annual 4th of July show. The city manager selected Acme because they have 4 different kinds of fireworks. Each firework explodes when it reaches its highest point in the air. Now, I don't know about you, but when I see highest point, I think of a maximum value. Once the rocket explodes, the sparkles fly out and stay in the air for the same number of seconds that it took the rocket to reach its highest point. So basically, the firework launches, it explodes, and then the sparkles come down at the same amount of time. So basically, they're saying that if we were to trace the trajectory of the firework, we would get a parabola, and it would be symmetric, so it would have an axis of symmetry. And boy, those are things that we've just talked about. All right, so that's what we're looking at here. There's a whole bunch more information, blah, blah, blah. I'm glossing over it because we're not going to answer every single question. This is supposed to be done at the end of the unit, but I know y'all are wondering, why am I showing you how to find a vertex? What am I ever going to use it for? Well, I figured I would go ahead and start with Acme Fireworks now. You'll see in my directions that we're going to only talk about questions 1 and 2. We're going to save questions 3 and 4 for December, okay? So the first type of firework we're going to trace is the Blue Bombers firework, okay? The Blue Bombers firework has an equation of 81 minus x squared. So the graph is a little misleading because remember, we're dealing with time here, and then we're dealing with height here. And this is in feet, and this is in seconds. So what you'll notice is the high point actually happens here at time 0. So the high point, it's not just the high point, it's the explosion. Happens at time 0. And I don't know about you, but I don't want to have a firework explode at time 0. What if I'm still holding it? Sometimes you do that. All right. So you'll notice that the high point is what we call the maximum. And how do we find the maximum? Well, usually in a parabola, the maximum is the vertex of the parabola. So basically, I am asking you to find the vertex of this parabola. Now, I've given you the graph, and you can see that it occurs at 0.81. But suppose you didn't have a graph, okay? So that's what we've talked about previously. So that's what I want to go over now. So I've got the function f of x equals 81 minus x squared. And I actually have a little more of this function. I want to think of it and write it in descending order like this. Remember, finding a vertex is as easy as ABC. So I need to know what A is, I need to know what B is, and I need to know what C is. Well, I know that A is -1. I don't see a B, so it must be 0. And then I've got a C of 81. And Robodeer, you're already killing me. How do I know that B is 0? Well, I'm going to write this one more time, and I want you to check this out. So I'm going to write my quadratic term. I don't see a linear term, so you're thinking of it as being zeroed out. And then I have my constant term. Okay, so there it is. And now I'm going to find my vertex. And in order to find the vertex, the first thing I need, remember, is the x-coordinate. Okay, so the x-coordinate has a formula. We're going to take the negative of the b term and divide it by 2 times the a coefficient. So I want the negative of b, which is 0, divided by 2 times -1. We'll get 0 divided by 2, which is 0. Okay, so right now, I know my vertex is 0 something. I have to find that something. Well, that something is the corresponding y, or the corresponding output when the input value is 0. So what I need to do is find f of 0. So I'm going to take the negative of 0 squared plus 81, and I'll get 81. So it looks like my vertex is 0, 81. Okay, if this were just, here's any old graph, I would just answer 0, 81. But they've given me context. They've given me meaning here. They're saying at time 0, the blue bomber will explode when it is 81 feet high. Okay. I should say, this one should have a caution. The blue bomber will explode at time 0. In other words, as soon as you light it and launch it. So, those are the people that don't mind having their fingers blown off. Okay, so there we are. Now, how high is the rocket when it explodes? It's 9 feet. How many seconds was the rocket in the air before it exploded? Well, if you trace it, they launched it here at -9 seconds. That's a domain question, so I'm really not going to focus on this one. Later, we'll talk about how many seconds did they stay in the air, and you can see from the graph that it stayed in the air for 9 seconds. But these are things down the road. This is a 0. This is a 0. Darn, those are things that we've discussed before, so keep that in mind, okay? All right. The next one, our next type of firework is the red rocket, and it follows a function, or it's defined by the function -2x squared plus 21x minus 90. And I actually graphed that one for you as well. And this one's really nice. You can see that there's a 0 here. There's another 0 here. The maximum is here. That's what I'm looking for. And I'm going to guess 5, 6, 7, 8, 9, 10. I'm going to guess it's going to be 7 point something, but 7 point something doesn't work for me. I need an exact answer. I need the x-coordinate of my vertex. So let's make our assignments here. A equals -2, B equals 29, and C equals -90. Okay? So to find the x-coordinate of our vertex, it's the negative b, the negative of b divided by 2 times a. So it's the negative of 29 divided by 2 times -2. So -29 divided by 4 is 7 1/4, also known as 7.25. So my input value is 7.25, and I'm going to substitute that everywhere that it's where I see an x in the function. And I am a firm believer in work smarter, not harder. So I have my good friend TI here to help me. So I'm going to take the negative. I'm going to take -2 times 7.25 squared plus 29 times 7.25 minus 90, and I get 15.125. Okay, big deal, Robodeer. What does that tell me? Oh my gosh, that tells me so much. So my vertex is the x coordinate with its corresponding y coordinate. Input corresponding output. That is the ordered pair of this point. That's what that ordered pair is, okay? But guess what else it tells me? It tells me the red rocket will explode when it reaches 15.125 feet high. And that happens 7.25 seconds after it is launched. Okay, there we go. And that's how that one works. So last week, I just gave you this bit of information, and you had to tell me what the vertex was. Well, now I'm giving you this information, and I'm giving you a graph because I do think you need to see it. But you can see what happens here. So someone stands here, launches the firework, it explodes, and then all the ash rains back down. Okay, that's what the maximum means in this problem. That's what the vertex means. 7.25 seconds, remember, that's what we're measuring horizontally, and a height is what we're measuring vertically. Okay. All right. This one, the green gammas, it has the function k of x equals negative x squared plus 12x minus 15. I had two different graphs for this one. I just wanted to show these to you because if you were to look at this, people would say, oh, this one's higher because physically the graph is taller. But look, that's just above 20. This is just above 20. You know, this is how you can mislead people with information. Just mentioning that. So I know for this problem, A equals -1, B equals 12, C equals -15. Okay, so I'm going to take this information. You know what? I think I can. No. I'll put this down here. But I want to refer back to the graph, so I'll keep everything handy. So let me rewrite this. Our function is k of x equals negative x squared plus 12x minus 15. We've already assigned our A, B, and C. So the x coordinate of my vertex, the axis of symmetry, is the negative of B divided by 2A. So it's the negative of 12 divided by 2 times -1. So 12 divided by 2 is 6. So my x coordinate is 6 of my vertex. It is, look, here's 6, 7, 8, 9, 10. You get it? So it's 6 comma something. And it is also my axis of symmetry. It's the line x equals 6. All right, so now let's find k of 6. That's going to be the negative of 6 squared plus 12 times 6 minus 15. And again, we're taking negative of 6 squared plus 12 times 6 minus 15. I get 21, which does seem to fit. Okay, so my vertex is 621. Big deal. What does that mean, Robodeer? It means 6 seconds after it is launched, the green gamma will explode at a height, explode. Okay, at a height of 21 feet. So I've used the 6, that's my time, that's my independent variable, my value. It will launch at 21 feet. So X, Y, time, height, independent, dependent. And regardless of what graph I use, I went 6, and this is just over 20 at 21. Here again is the same vertex. Let's see, 2, 4, 2, 4, 6, 8, 10. So there's my X coordinate of 6. And then my Y coordinate, my height is 21. So there we go.
Okay, I drank 1% milk, or you use 1% milk.
Thank you. All right, and so my last one is orange orthogonals. It's already spelled out for us. Again, you can see the graph. You see that my maximum should occur before 5. Thank you so much. So I'm going to assign A equals -6, B equals 53, and C equals -91. So to find the X coordinate of my vertex, remember it's -B divided by 2A. So it's -53 divided by 2 times -6. So we have -53 divided by -12. And y'all, it's come to the point where I have to show you, and we have to have a conversation about rounding because it's all proper units and whatnot. So I'm going to take -53 and divide it by -12. Oh, and I need a decimal. So I want to turn this into a decimal, which is right here. Fraction to decimal, F to D. If you ever see it on a calculator, it will turn a fraction into a decimal for you. So I get 4.41666 all the way to 7. I'm going to make this decimal 4.42 because the 6 tells the 1 to round up. It's sad that I have to remind you of that, but sometimes our brains stop working after a while and we need to be reminded. So there we are. So my X coordinate is 4.42. My axis of symmetry is X equals 4.42. Okay, so half of the time the firework is flying up, the other half of the time the ashes are flying down. Okay, so to find the Y coordinate, I'm going to find H of 4.42. So that'll be -6 times 4.42 squared plus 53 times 4.42. And I'm using my calculator on this one. So we'll take -6 of 4.42 squared plus 53 times 4.42 minus 91. All right, so we get 26.0416. We'll just leave that here. Okay. So my vertex is 4.42, comma, 26.04. Now, if this were just some ordinary math problem, that's all you would have to do. However, this problem is part of a story, so I need to report the story. So I will say the orange orthogonal, oh, good grief. The orange orthogonal means perpendicular, just so you know. Orthopedic surgeon, make sure you stand up straight, perpendicular to the floor. You go to an orthodontist to make sure that your teeth are perpendicular to your gum line. Yeah, man. The orange orthogonal rocket will explode 4.42 seconds after launch at a height of 26.04 feet. So there we go. So for the first 4 problems in this task, they give you a function and they want to know the particulars. When does it explode and how high is the rocket when it explodes? And then they give you a problem number 5, which I've sort of adjusted just a little bit, okay? So they want you to be able to make an equation. And we've done a very good practice of making equations when I give you the vertex or making functions. So that's what we want to be able to do here. So I'm sorry, I'm cleaning up my sheet here because I did have to make an adjustment, okay? So here it is. Now that you're officially an expert at evaluating fireworks, the Acme Fireworks company would like for you to write an equation for their new ultimate firework called the Golden Fractal. The company wants the Golden Fractals to explode 65 feet above the ground, and they want it to, they want that to happen after 8 seconds. So this piece right here explodes 65 feet above the ground. Here's what they're really saying. They want, if we were to graph this, the vertex of it will be after 8 seconds, we have a height of 65 feet. That's really what they're saying. That's why I love math, because it's so concise or succinct. I don't have to use all kinds of words if I don't want to. Please, I'm sorry if anyone is an English teacher and watching this, but it's okay. So I basically want that equation. So if I know the vertex and I know that this thing will, let's look at a picture. So this is going to shoot up and then explode after 8 seconds at 65 feet. And since I see that this is a parabola that's upside down, I know that A is negative. To make my life easier, I'm going to just use -1. Okay? So remember, the function is x minus h squared plus k. Oh, I'm going way back. So this is h, this is k, here's -1. So this is -1 times x minus -8, x minus -8, I can do that, I don't mind, plus k. So we'll get -1 times x plus 8 plus 65. And so if I were to expand this, squared, we'll get x squared plus 16x plus 64. You can either do that by boxing it or foiling it, okay? And when we distribute, we'll get -x squared minus 16x minus 64 plus 65. So my final equation is this one. Okay? So you've learned it forwards and backwards. I've given you the equation and asked you for the vertex or the particulars. Then I give you the particulars and I want you to give me an equation. So when you're given an equation, find the axis of symmetry, the x-coordinate of the vertex. Because once you know the x-coordinate, you substitute into the function and you can find the corresponding y-coordinate. And then that gives you a time and a distance. And there it is.